Welcome back, guys. Lesson 8 in Unit 8, and we're talking about moles and stoichiometry. Well, in the previous lesson, we talked about balancing chemical equations. Now we're going to look at the different types of chemical reactions. So now that we can balance them, we should be able to determine what type of reaction is occurring based on the species that are present in that reaction. So type 1, the first type of chemical reaction that we're going to look at is called a single replacement reaction. And a single replacement reaction is a reaction in which one species replaces another alone on one side and combined on the other. So, for example, I have 3 examples here, and then we'll have a general formula that this one will follow. So, for example, here, a single replacement, what you can see here is that silver is replacing the gold in one species and becoming AgCl, and then Au becomes an element by itself as a product. So Ag replaces that, and then the Au comes out by itself. The second example, we have chromium reacting with hydrosulfuric acid, or aka sulfuric acid, in which the metal by itself will replace the first positive ion in the next compound. So now you end up with Cr2SO4 and then hydrogens by itself. So the hydrogen then comes out by itself. So it's basically a switch off. So in the last example, we have chromium replacing iron, and notice how it's always the first element that's replacing, or the single element that's replacing the first positive ion in the compound in the reactant, okay? So now you can see chromium is combined with the CO3, which is the last part of that compound, and then the iron comes out by itself, and you'll see that on the end. So this will generally look like A, something by itself, plus a compound, Bc, ionic compound, to form Ac, where A is combined with the negative ion in Bc, and then B will be by itself, which should also be a metal. The second type of reaction that we look at, chemical reaction, let me stress that, is double replacement reaction. Okay, so it's very similar to single replacement, in which now we're looking at a reaction where 2 compounds react, they switch partners and produce 2 new compounds. So this is very, very important because the reaction is between 2 compounds. If you notice on single replacement over here you have one thing by itself and then a compound. Here we have 2 compounds. So here are 3 examples. We have lead nitrate combining with sodium chloride to produce lead chloride and sodium nitrate. So what really happens is that these metals switch places. Second example, sodium phosphate silver nitrate becomes silver phosphate sodium nitrate. Okay, it's a double switch off. The last example, potassium carbonate combines with silver nitrate to become potassium nitrate and silver carbonate. So remember, those polyatomic ions stay together in those compounds. Great. So the second type will generally look like this, where you have AB, which is an ionic compound, plus another ionic compound, CD. In this case, B and D are both negative ions or polyatomic ions, and AC are metals or positive polyatomic ions. This will form a double switch where you end up with AD together and BC, just like the examples that we just went over. Now, the third type of chemical reaction that we need to memorize and be able to recognize is something called synthesis. Well, as you know, synthesis is to make something or synthesize. So in this reaction, we are going to take more than one reactant and create one product. So this third type can also be called a combination reaction because you are actually literally combining 2 things to create one new single product. All right, so here are two examples. You have aluminum combining with oxygen to form aluminum oxide. You have hydrogen and oxygen to form 2 moles of water. So this reaction is going to look like this. And remember, these are just skeleton equations, so you fill them in with the reactants and the products as you see them in your chemical reaction and equation. So you have A plus B, 2 species, creates AB. Just combine them. Just make sure that the equations are balanced. Remember, all chemical equations have to be balanced to follow the law of conservation of matter and mass. Anyway, all right, the last type we're going to discuss in this lesson is decomposition, and it's kind of just exactly how it sounds, decompose, to break down. So this is a reaction where we take one reactant and create 2 new products. Very simple. So 3 examples here. We have barium carbonate. What we do, we break it down into its parts, where we end up with barium oxide and carbon dioxide. So see how we start with one thing and now we have 2 and 3, 2 new products. Same thing down here, hydrogen peroxide to form water and oxygen. And the last one is bismuth hydroxide to form bismuth oxide and water. So these are all considered decomposition reactions in which you have to look to see how many reactants you have versus how many products. So this one will look very similar to a decomp, but basically, I don't want to say similar, but it will be the opposite. So you end up starting with AB and you end up with A plus B. Okay? So AB is the compound on the left, one single reactant, and then as it undergoes decomposition, then we will end up with 2 separate species. Now they could be compounds or they could be by themselves, but A would represent a new product, whether it be an ionic compound or an element by itself. All right, so that is the end of lesson 8, in which I summarize the chemical reactions in which you will be required to identify in your practice packets as well as on the Regents. You need to be able to pick out what type of reactions are occurring in the chemical equations that are given to you. All right, thank you guys.